What if the next major breakthrough in India's semiconductor journey does not begin in a massive fabrication plant, but with an Indian startup designing a chip for broadband connectivity? That is exactly what Aheesa Digital Innovations is attempting with VIHAAN, a broadband networking system on chip designed in India and built using the Indigenous VEGA microprocessor. Aheesa Digital Innovations is a Chennai-based fabless semiconductor startup focused on chips for broadband networking and security. Its latest achievement is significant. VIHAAN has achieved first-pass silicon success, meaning the first manufactured version of the chip has successfully worked as intended. The chip was taped out on Republic Day and achieved first-pass silicon success on Independence Day this year. It will now move towards production tape-out targeted for 2027. Why is this important for India? Semiconductor chip design is one of the most valuable parts of the semiconductor value chain. According to the Ministry of Electronics and Information Technology, chip design can contribute up to 50% of overall value addition and account for approximately 15 to 35% of the bill of materials cost of electronic products. Therefore, developing indigenous chip design capabilities is critical not only for economic growth, but also for technological sovereignty and strategic security. This is where the Design Linked Incentive, or DLI scheme, becomes important. The scheme supports Indian startups working on semiconductor designs for applications ranging from satellite communications, drones, and surveillance cameras, to defense, aerospace, automobiles, IoT, artificial intelligence, telecom equipment, and smart meters. Aheesa is one of the companies emerging from this ecosystem. VIHAAN is specifically designed for the rapidly expanding fiber broadband ecosystem. As India expands optical fiber networks, 5G and broadband-based digital services, the demand for domestically designed networking chips is also increasing. The objective is not simply to design a chip, but to create products that can eventually move into commercial production and global markets. Investor confidence is another important indicator. Earlier this year, Aheesa raised around Rs 40 crore from the Tamil Nadu Infrastructure Fund Management Corporation through the Tamil Nadu Emerging Sector Seed Fund, along with other private investors. This funding is expected to accelerate product development and support the company's growth in the semiconductor sector. The successive funding rounds following DLI approval indicate increasing investor confidence in India's ability to develop advanced semiconductor solutions. But Aheesa's achievement is part of a much larger transformation. Under India's semiconductor programs, advanced chip design tools have been made available to 455 organizations, including 350 academic institutions and 105 startups. Companies supported under the DLI scheme have cumulatively raised more than $100 million in venture capital funding and achieved over 30 chip design tapeouts across various foundries. Under the Chips to Startup, or C2S program, 245 chip designs have been taped out by 71 academic institutions, helping build India's future semiconductor workforce. Several other Indian companies are also demonstrating this growing capability. VIHAAN Microelectronics achieved first-pass silicon success with a BLDC motor controller. Netrasemi successfully tested a 12-nanometer vision SoC with integrated video analytics acceleration. OptoML received its 12-nanometer compute-in-memory SoC, designed to make AI processing faster and more power efficient. Mindgrove Technologies is exploring the use of its Vision SoC in CCTV surveillance cameras, while Indisemi secured global certification for its Bluetooth Low Energy 6-chip module. Together, these developments indicate a transition from chip design on paper to silicon-validated products, and that distinction is extremely important. India is not merely trying to create individual semiconductor designs. The broader objective is to build an ecosystem covering the entire value chain: design, fabrication, advanced packaging, equipment, materials, research and development, and skilled manpower. This ambition has now entered another phase with Semicon 2.0, approved in July 2026, with an outlay of Rs 27,500 crore. The objective is to build a globally competitive semiconductor ecosystem and strengthen India's position in the global electronics and semiconductor value chain. It connects with Atmanirbhar Bharat, strategic technology, digital infrastructure, semiconductor sovereignty, deep tech innovation, industrial policy, employment, and global value chains. The larger transformation is clear. India is moving from being primarily a consumer of semiconductor technology towards becoming a designer, developer, and eventually a global supplier of semiconductor solutions.